Hello everybody. Today we're going to learn about the characteristics of quadratic functions. A parabola is a graph of a quadratic function. Each parabola has a line of symmetry, which is also known as the axis of symmetry. The line of symmetry divides the parabola into mirror images. The line of symmetry is always a vertical line of the form x equals n, where n is a real number. The x-intercepts are where the parabola crosses the x-axis. X-intercepts are also known as zeros and roots. When you solve a quadratic equation, you are finding the x-intercepts. The y-intercept is where the parabola crosses the y-axis. The turning point of the parabola is called the vertex. The vertex will either be a maximum or a minimum value of the graph. It will be a maximum value if the graph is a downward facing parabola. So what that means by downward facing is that your parabola looks like this. This point right here is our vertex, and because it's the highest point of the graph, that makes it a maximum value. This will happen when you have a negative a value. We will have a minimum value when the graph is an upward facing parabola. So a graph that looks like this. Our vertex is the lowest point of the graph, making this a minimum value. This will happen when the equation has a positive a value. When we look at example 1, it says label the quadratic function below. So let's start off with the things that we know. We know that this is the x-axis and that this is the y-axis. This U-shaped curve is called a parabola. Where the parabola crosses the x-axis at these 2 points right here, these are called the x-intercepts. Where the parabola crosses the y-axis, that is known as a y-intercept. The vertex is the turning point of the parabola. In this graph, the vertex is a minimum value. The line of symmetry cuts the parabola into two mirror images, and it just goes straight through the vertex as a vertical line. Oops. And so this is the line of symmetry. So these are the basic vocabulary terms for a quadratic function. Let's look at example 2. It says identify the requested characteristics of the quadratic functions. So you may be familiar with some of these vocabulary terms, characteristics that we see over here on the right side of the screen. The domain are your x values, and we find them from left to right of the graph. So my furthest point to the left, well, my graph is going to the left forever. I can see that because I have this arrow here telling me that it's continuing in this direction forever. And so if I keep going to the left forever, my x values are going to get more and more negative the more I go to the left, and so eventually I'll end up at negative infinity. My furthest point to the right, well, that's this right here. And I know that this is going to continue on to the right forever because of the arrow. And if I continue going on in this direction forever, my x values are going to get more and more positive, and eventually I'll end up at positive infinity. So my domain is from negative infinity to positive infinity. which is the same thing as saying all real numbers. This R with an extra line is a symbol that represents all real numbers. If you don't like the symbol, you can just simply write out all real numbers. Our range is our y values from the bottom of the graph to the top of the graph. The bottom of my graph is my vertex in this case, and this vertex is at the point 0, -4. So my smallest y value is -4. This graph is going up forever. I can see that because on both sides of my graph, it's pointing up. Well, if I keep going up forever, eventually I'll get to positive infinity. And so my range is from -4 to positive infinity. -4 gets a bracket because it is included. It is on a solid line, and that is why it gets a bracket. Remember, your infinities always get parentheses because we can never get to infinity. As an inequality, this would be y is greater than or equal to -4. And that is because -4 is a minimum value and everything else is higher than -4. So on this side, everything is greater than -4, and on this side, everything is greater than -4. It's equal to because we have that bracket, because -4 is included. Our vertex, we said already, is this point right here, which is the ordered pair 0, -4. This vertex is a minimum value because it is on the lowest point of the graph. The line of symmetry is the line that cuts the parabola into two symmetric pieces, and it's always a vertical line. Vertical lines have the equation x equals a number, and here x equals 0. Your equation will always be x equals the x coordinate of your vertex every single time. Remember that zeros is another word for x-intercept. So here I have two x-intercepts. Our first x-intercept is at the ordered pair -2, 0. And our second 0 is at the ordered pair +2, 0. Our y-intercept is where our parabola crosses the y-axis, and in this case it happens to be the vertex, which is the ordered pair 0, -4. For increasing and decreasing, we're talking about our intervals. Whoops, I'm sorry about that. There we go. And when we're talking about intervals, we're talking about our x values. And so we're saying for what x values is our parabola increasing? And for what x values is our parabola decreasing? To figure out where your parabola is increasing or decreasing, we're going to trace our graph. You always trace the graph from left to right, just like how we read a sentence. It's from left to right. So from the left side, from left to right, when I start at the beginning and I go to the vertex, this is going down. And so this side over here is decreasing. So because I'm decreasing, now I want to figure out for what x values is this part of the parabola decreasing. Well, I'm starting at -infinity for my x values, and I keep going until I get to my vertex, which is where x is 0. So I'm decreasing from negative infinity to 0. And so that's what I'm going to write for decreasing. Negative infinity to 0. Now, from my vertex to the end of the graph, over here, I go up from left to right. So this side over here is increasing. So now I need to figure out for what x values is my parabola increasing. Well, I start right here at my vertex where x is 0, and I keep going up until x is infinity. So I am increasing from 0 to infinity. The reason why the zeros are using the parentheses as opposed to a bracket is because 0 is the vertex, and the vertex is the turning point. 0 cannot be both decreasing and increasing at the same time. And so that's why we're using the parentheses here. To say at some point when we hit 0, we switch from decreasing to increasing. And so that's why the parentheses are there. The last characteristic that we're going to look at for this problem is end behavior. The notation for end behavior is as x approaches negative infinity, we want to figure out what y is doing. And as x approaches positive infinity, we want to figure out what y is doing. So as x approaches negative infinity, again, we're looking at the left side. So as x approaches negative infinity, my graph is pointing up. Well, if it's going up, then y is going to positive infinity. As x approaches positive infinity, that's telling us to look at the right side. The right side of my graph is pointing up. So if it's pointing up, that means that y is going to positive infinity. What I would like you to do is go ahead and pause this video and see how many characteristics you can get on example 3. When you are ready, continue the video. So if we look at the domain here, our domain is our x values from left to right. My graph is going to the left forever, so that is going to negative infinity. My graph is going to the right forever, so that's going to positive infinity. So my domain is from negative infinity to positive infinity, which is the same thing as all real numbers. Your range is your y values from the bottom of the graph to the top of your graph. This graph is going down forever, so that's going to negative infinity. The top of this graph is the vertex. Here our vertex is at the point 7, 1. So my y value here is 1. So my range is from negative infinity to positive 1. 1 is included because it's on a solid line. Infinities are never included because we can never get there. As an inequality, everything is below my vertex. So everything is below this point. And so my inequality would be y is less than or equal to 1. The vertex we just said was 7, 1, and that's an ordered pair. This vertex right here, it's a maximum value, and that's because the vertex is the highest point of this graph. The axis of symmetry is the same thing as a line of symmetry, and it's a vertical line that splits the parabola into two mirror images. The equation of the axis of symmetry is x equals 7. Again, that value always comes from the x coordinate of the vertex. The roots are the same thing as the x-intercepts. I have one root right here at the point 6, 0, and I have another root right here at the point 8, 0. For increasing and decreasing, we trace our graph from left to right, and we figure out for what x values is our graph increasing, and for what x values is our graph decreasing. So if I trace my graph from left to right, I'm going up until I get to my vertex. And so this side over here is increasing. And so I am increasing, from my negative infinity until I get to my vertex where x is 7. So from negative infinity to 7. So negative infinity to 7. And then when I'm at my vertex, I start to decrease because now it's going down from left to right. So over here we are decreasing. And so we are decreasing from when x is 7 until when x is infinity. And then for our end behavior, as x approaches negative infinity, we want to figure out what y is doing. And as x approaches positive infinity, we want to figure out what y is doing. So as x approaches negative infinity, that's telling us to look at the left side of the graph. The left side of my graph is pointing down, so that's going to negative infinity. As x approaches positive infinity, that's telling us to look at the right side of the graph. My right side of the graph is pointing down, so that's also going to negative infinity.